Okay, so let's take a look at the repeating decimal problem. So part A, the repeating part is 0.3960. So we got 4 chunks here, and then it keeps going. Now the first chunk right here, I can write that. Whoa. Wonder if you saw that or not. Okay, the first one is 3960 divided by, what is that, 10,000. The second one is 3960 divided not by 10,000, but actually 10,000 times 10,000, which is going to have an awful lot of zeros here, but I'm just going to write it as 10,000 squared. This third one will be 3960 over 10,000 cubed. And it just keeps going. Now, I think I prefer to write this with decimals just to keep it a little cleaner looking, because otherwise I tend to get confused with all those fractions that get so big there. So I'm going to write it like this. Squared plus 3960 times 10,000. Oh, whoops. Not 10,000. 0.0001. Whoops. Sorry. First one's not squared yet. Second one's squared. Then 3960. 0.0001 cubed plus dot dot dot. So there's my sum. That's the number that I want. Now notice this is an infinite geometric series. R is 0.0001, and R is between 1 and -1. And so these three things tell me right here, well, really the fact that it's infinite and that R is between -1 and 1, infinite geometric, tells me that it's got to converge. Okay, so what does it converge to? All right, well, we can use the shortcut. First, the real method is multiply both sides by 0.0001, and you'll get a new equation that you can line everything up right below, and then you can cancel out a ton of stuff when you subtract one equation from the other. Now, if you do that every time, you start to realize that you're actually getting this. You're getting the first term over 1 minus r every single time. Now, the first term is 3960 times 0.0001. Okay, remember it's not just 3960 in this case. There's actually this ratio right here already multiplied. And then it's over 1 minus the common ratio, which is that 0.0001. So this ends up being 0.396 over 0.9999. And I probably prefer to think of it that way, because then it's easier to see. Move each decimal 4 units over, and you get this. And if we divide that, let's see, 9's got to go into both of those. So 3960 divided by 9 is 440. And that divided by 9, that's easier. 1111. I know 11's got to go into both of those. So this is going to be 40. This one's going to be 101. And I can't get any simpler than that term right there. Sure, let's try B. Now, I haven't worked out B yet, so I don't actually know if I'm going to get this right. Let's see. Oh, this one's mean. So this is mean because the first 4 numbers are not anything in the repeating pattern. The repeating pattern starts here at 27, 27, 27, 27, 27, 27. Oh, that's so nasty. So the way this one works is you actually have to separate out the 0.5275 from everything else first. Oh, that is mean. I don't know why I would write. I must not have written this one. So 1, 2, 3, 4 zeros, and then 27, 27, 27, 27. All right, so let's see what we can do with this. This is the part that we really have to kind of pay attention to. This part we can already write as a fraction, 5275 over 10,000. This is the one that we're going to have to deal with. So let me work this out on the side here. Okay, so the first term is 27 over, what is that? 10,000. 100,000? Let me make sure. 20, let's do 27 divided by 10000. No, it's 27 over a million. 1 mil. There we go. 2.7 times 10 to the negative 6. Let's make sure. Or, that's not negative 6. 27 divided by 1 million. 0.000027. Yeah, that's right. Okay. So the next one is 27 over a million times, and it's moved over 2 more decimal places, so that's times 1/100. Then the next one's going to be 27 over a million times 1 over 100 squared, because it's moved over 4 decimal places. And we can continue that. Okay, so the first term is 27 over a million. The ratio is 1 over 100, and that's between 0 and 1. So, or sorry, negative 1 and 1. It's still between 0 and 1. So, and it's a geometric series, so we know the series has to converge. And it has to converge to A over 1 minus R. So A is 27 over a million. And 1 minus R is 1 over 100, 1 minus 1 over 100. And let me type that in and see what that equals. Let's see, that's going to be 199 over 100. So, yeah, that's right. Oh my gosh, this is so gross. All right, so that's going to be 27 over a million. Yeah, over 99 over 100. So let's see, this 100 will cancel out 2 of those zeros. So now I've got 27 over 10,000 over 99, which turns into 27 over 99 times 10,000. Oh my gosh, this is so nasty. So let's see, those are both divisible by 9, so that would turn into 3 over 11 times 10,000. And I still need to combine it with this, so let me put this over here. 3 over 11 times 10,000. And so I need a common denominator, so I'm going to multiply this one by 11 over 11. And so now I've got 11 times 5275 plus 3 is 58,028 over 11 times 10,000. Well, that's going to be 110,000. Let me make sure. At this point, this is all crazy. Yeah. All right, and then we can simplify this a little bit. So, what definitely goes in? I'm just going to divide. I'm going to start small. 028 divided by 4. So that's 14,507, and then 11,000, or sorry, 110,000 divided by 4 is 27,500. Oh my gosh. At this point, I'm typing this into the calculator and seeing what it simplifies to. Math fraction. It doesn't give me anything. I'm going to say that's as small as we can get for now.